today we're going to look at enthalpy past paper questions. Please can you make sure that you have a copy of them available and that you have any flashcards that you've made during this topic available as well. Now some of you may wish to skip through the video to find the question that you found difficult to answer. The others of you may want to go through this to find out where the marks have been awarded. Okay, the first question is a definition. Definitions are very important in the enthalpy part of this course because they are very precise and you need to make sure that you have learnt them off by heart. My suggestion is that you write flashcards for all of your definitions, and you can get those definitions from your textbook or from the syllabus. The way to remember them is possibly doing read, cover, write, check, just as you did when you learnt your spellings when you were younger. You may also find that an app for your phone is useful so that you can have a little memo pad with all of the definitions on that you can flick through to help you whilst you're perhaps travelling home on the bus. Here we go. Define the standard enthalpy change of combustion. Okay. Whenever you see the word standard, you have to make sure that the standard conditions are stated. And so we're going to start off with the enthalpy change when 1 mole of a substance is completely combusted in excess oxygen under standard conditions. Now I'm going to check the mark scheme. It says here that it's worth 3 marks. For those 3 marks, I have to state that I've got 1 mole of my substance and that I'm only burning 1 mole. I also have to say that it is completely combusted. And you can say that by putting in excess oxygen as well, because then we know that every carbon atom, for example, in a hydrocarbon has been made into carbon dioxide, and every hydrogen in a hydrocarbon has been made into water. We've got no incomplete combustion products which have a different enthalpy value. For 3 marks, I may need to state what these standard conditions are. I'm not entirely sure yet, but I have stated that they need to be under standard conditions, and these are of temperature and pressure. And the temperature value is 298 Kelvin, capital K is a scientist's name, and 100 kilopascals. Make sure that you have a flashcard that represents that definition, and we'll move on to question number 2. This one is also a definition, but I'm going to just check through the question. Don't skip straight to the answers. We're just going to check through to make sure that we've got all the information we need. So this one says alkanes are important hydrocarbons, so they only contain hydrogen and carbon atoms, and they're used as fuels. And fuels are used because they generate energy in the form of heat, and it's important that we know what these values are so that we can compare them. So define the enthalpy change of formation. What am I going to make this compound out of? Let's find out. So this is the enthalpy change. Again, when 1 mole of a substance is formed. And it's going to be formed or made from its elements. And they're the ones that obviously make it up, and they're called constituent elements. Now this is only worth 2 marks according to my scheme down here, but again, if I'm not entirely sure, I think I ought to state that the elements that my new compound is going to be made from, well, those elements have to be in their standard states. So I'm going to add the elements, its constituent elements, in their standard states, and this is all done under standard conditions. And we know that they are 298 Kelvin and 100 kilopascals. Now again, you might want to make sure that you have a card with the enthalpy change of formation on. If you're not sure what in their standard states under standard conditions means, that's where if I was going to use hydrogen, hydrogen is a gas at room temperature, which is 298 Kelvin, and 1 atmosphere pressure or 100 kilopascals, whereas carbon is a solid at that temperature. And in fact, carbon is an example where we have to sometimes state that it is a solid and it's found in the form of graphite, because carbon has different allotropes. Allotropes are the same element which have got a different molecular arrangement or atomic arrangement. So this is not required in this question, but you may need to go and look up the word allotropes to find out what that's all about. Okay, now we're writing an equation. Let's have a look at what's expected in this question, including state symbols. That's S for solid, L for liquid, G for gas, or AQ for aqueous. They're solutions made up in water. So we're looking at writing a balanced equation for the formation of hexane. There's lots of information in this question because the examiners told me that hexane is a liquid at room temperature. I may not know that, I wasn't sure, but they've given me the information and they want me to use the state symbols, so I've got to make sure that I do that appropriately. So I'm going to be forming C6H14, and it's a liquid. I've been told that. And I'm only going to make 1 mole of it, so I'm not going to add any more atoms in. This is 1 mole of it. Okay, and what am I going to make it from? I'm going to make it from carbon atoms, and carbon is a solid at room temperature, or standard temperature and pressure, and hydrogen. And I know that hydrogen is diatomic, goes around in pairs, and it is a gas at room temperature. Okay, let's just check how many of those I need. If I go to this side, there are 6 carbons in hexane, so I will need 6 carbon atoms to make that. And there are 14 hydrogens here, so I will need 7 pairs of them, 7 pairs of H2 to make 1 mole of hexane. Now, I do not have to put the 1 in here, so I'm just going to rub it out. And that's my balanced equation. Let's just check, it's worth 2 marks. State symbols, just check I've got them all in. Yes, that's that one. Sorry, and this one here, so I've got my state symbols. Have I balanced the atoms up? Yes, I have. Right, I can move on to the next question. What conditions of temperature and pressure are used? We've already stated that in the previous question. The temperature is 298 Kelvin, and that's equivalent to 25 degrees C. And pressure is 100 kilopascals. Again, be careful, Kelvin is in capital letters, pascals is in capital letters because it's a name, but the kilobit is in lowercase as it denotes 1,000.